Hi, everyone. So my name is Ahmed, and I'm presenting for today's topic, Introduction to High Performance Computing and Cradle. Like I've included Cradle as well to introduce what we do in our data science projects. So if there is any question related to me, you can contact me through this email ID xk962, or you can come to our lab SGLE 540 in this building. So these are the agenda for today. Overview, what is HPC about? Hi. What is HPC about and what we do, then how to connect to HPC, then how our Cradle is related to HPC, then if you're working on HPC, what you have to do, then how can you seek more help if you're working on HPC. Yeah.
Is there a persistent link on the SDLE website for the links to the old last week's screen?
You mean like, is there any, like if you search for SDLE Research Center, you will get all our videos? Is this your question?
So I can't go to the SDLE public web page and find the
Oh,
links.
No, I don't.
I have to go
Yeah.
to YouTube and search SDLE to find them.
Or you can use our flyer, and then you can scan the code,
Okay.
and it will take you to the YouTube page.
Okay.
So yeah, overview, like HPC is high performance computing research environment. We use Rider cluster. It is offered by Research Computing and Cyber Infrastructure, RCCI at CWRU. And they are sitting right at the back today. And they are like useful when you have a large amount of data sets and you want to work on them parallelly. It can be helpful in running hundreds of parallel jobs. And then in SDLE, we have a large cluster for our data storage, which we use to keep all our building data set and power plants and many more data sets. And then support from it. And if we are unable to like do something or work something, we get the support from HPC team, which is like really helpful, especially when we are working on Linux environment. So this is the architecture of HPC, how it looks. I think it's updated. So it's kind of divided into some parts. So these are the core. So these are the cores that we have, and it's called the compute cores. So overall, there are 3,500 compute cores. Then we have some of the GPU cores. It's written here 58,000, but I think it's over 100K now. So, and this is the login node. So whenever we access HPC, like we write, I will explain in the future slides. So whenever we access by rider.case.edu, we access this login node. And from here, we navigate to different compute. If we want to do some operations or some computation, we would go to compute node. If it's going to be some graphical processing, then we will take GPU cores. And in Cradle, if we want to go to Hadoop cluster, we would go to this master node, which would take us to this cluster. Is that clear? Okay.
What is Hadoop cluster?
So okay, yeah, that's a good question. So in our high performance computing system, we have compute cores, GPU cores, and some others which I don't know, but they are maintained by HPC. And in the same high performance computing, we have Hadoop cluster, which is specific to SDLE Research Center, which is not open to everybody. So that's why I have given kind of a special focus to this one. And this is a detailed structure of what we have in our cluster, like I mean HBase Hadoop cluster. So we have HBase in the Hadoop, and we have these many tables here. It's just, if you're not from SDLE, it's just to give you an exposure what you can do in your research lab, or what are the possibilities of HPC. So this is what we are doing in HPC. So this is the Hadoop cluster, and in Hadoop cluster we have HBase, which is kind of our database where we maintain these tables here. Then we have HDFS, which is a file system, like we have a file system in our Linux or Windows. Similarly, this is also a file system for Hadoop, and it has, like, these are our descriptions for it. It has H node from where we log in. It has 2 master node, some data node, which is similar to kind of compute node, if you say, because we do most of our computation here. Then Thrift server, which lets us connect to HBase if we are working on R or Python. Then it has 180 cores, like all these 12 data nodes collectively have 180 cores, and this is the disk space we have, and this is the memory that we have on the cluster. And this database is connected through to R, Python, or Apache Spark by these packages, CradleTool packages, which are rcradletools for R and PyCradleTools package for Python. These we are going to discuss tomorrow. So if you're interested how we do these kinds of stuff, that will be covered in tomorrow's topic. So whenever you want to access this HPC or Hadoop cluster, you have to go to the gateway node, which is a login node. Then from login node, you can go to the compute node, which like you have to access R or Python. So for this, you have to go to the compute node, which will give you Cradle to R or Python package. And then you can access the database. I would take you to the demo also to make it more familiar. Like any question, any understanding or something like that? Okay. So this is how so there are different ways to connect to HPC. First of all, the most simple is, I think, if you do SSH from terminal, if you are used to the terminal. So I would take you to this. And so this is my terminal window, and I'm on my local laptop, so I don't have access. So to access HPC, I would do this. Simple. So this is my login name, and this is the server that I want to access. Ask for my password. So if you see here, I have moved from VUV24 to HPC3. And here you can see, like, from your host name, like, where are you? It's going to be HPC3, but yeah, that is the way to see where are you. And so if we see on HPC, there are 2 login nodes. One is HPC3, and the other one is HPC login, which, so sometimes you will go to that. I think it's decided automatically. So if I would try next time, maybe I would go to HPC login node. Yeah, see? So these are the 2 login nodes. It would take you to either of the 2. Okay, yeah. And so this is one of the way to connect. And you can see, like, who am I is the command which will give you the username and the host name. And there are different commands. I will take you through all of these. First, let's see the different methods to connect to HPC. And the other one, the most popular, is X2Go client. This is recommended by HPC if you want to use graphical interface. And so let me also show how to use this. So if you are logging in for the first time, you will not find these steps here. So you will go to a new session, then create a new session. So the host will remain same, rider.case.edu. Login would be my user ID, which is my case ID. Then there are some preferences which we want to set, which are recommended by HPC. If you're using it in via your LAN or in your lab setup, you want to scroll it to LAN. And in media, you want to disable this so that you use less of a bandwidth. These are the recommendations.
Sorry, I have to install this thing?
Yeah, X2Go client you have to install. Okay, so it's there on the HPC page. I would take you to that page towards the end where you can find how to install X2Go client. Yeah. Where? Oh, okay. This one?
Media, sorry.
Oh, okay, yeah.
Yeah, you want to disable also printing support. Client-side printing support.
Oh, yeah.
You want to disable both.
Yeah. So both of these. It's just to reduce the bandwidth because hundreds of people are accessing like HPC, I guess. And yeah, scroll this to LAN, and then media, and then session, and then case.edu. Oh yeah, and there's one more thing. If you go here, session preference, and there is a session type. So normally we use KDE, but there are others which are recommended by HPC. So I'm not aware of them, but yeah, KDE works for us. So I think it should work for you people too. Now it would ask for your password again. So I have already running like somewhere else. So what I normally do if I want to access the same session, I would suspend this so that I can access the same here. Now it's in suspended mode, and then I can resume it. So yeah, it's here. So yeah, again, the same thing, but the advantage here is you can access the graphical interface here. So now once you're an HPC, you want to see what are the modules that are available to you because whenever you enter on the login node, it's like the bare minimum that you have here, like no packages, nothing. So you have to look for the modules. That's how the HPC works. It's not like your simple Linux machine where you have everything installed and you log in and you get your packages. No, you have to load packages here, and this is called the module load. So I would see what are the availability here. So the command is module avail, and I can see like so many modules here. Some are related to OpenMPI, some are for just Intel. Yeah, Intel, and some are like different. So in SGLE, we use HPC ODS R if we want to run R Cradle tools or R Studio. And if you want to run Python, we run the different one, this one. It's
You make your
okay. Here is the command to clear the screen. So yeah, this one is for Python, and this one is for R. But if you're not from SGLE lab, you don't have to use this. So if you just want to run R, you can load this module. So the simple command would be, let me copy this, module load and R. But it would give me error because I'm on the login node, so it shouldn't run. Yeah. So before running RStudio or any of the computational tool, you have to move from login node to the compute node. So the command to do that is this is the default command that you want to use. And this is good enough for like normal tasks that you want to do. So I will start with this one. And sometimes if it's busy, you might get a wait time, but normally you get it pretty fast. So it shouldn't worry you, even though it's like it's taking some time today.
These commands are written in the presentation?
So this is like the recorded video. You can access these video from the SDLE Research Center, but I would try to write them, add them to the slides so that you can access it later on. Okay, so in the meantime, if it's running, let's go back to the slide. Yeah. So these are the instructions. So I could only access HPC right now because I was in the case network, or I'm connected to the case LAN network. But if I'm outside the network, first I will have to connect to VPN, which is Cisco VPN, which I have already downloaded. And this is the one. This is the one that you want to download. Okay, so maybe right now I'm in the case network, so it doesn't work. But you will find on the UTech webpage like this how to set up VPN, and this is the link to that. I think. Yeah, and this will like take you step by step how to set up a VPN if you are from outside, if you are in the outside the case network. Yeah, these are some of the commands that I have and the screenshot. So it's module avail, and what are the modules available to you at that time. Okay, and this is the screenshot of the Cradle cluster that I have shown initially. The one over here, this one, and this is all our like the data storage that we use. And sometimes we use PySpark, which I would take you a little bit. But before going there, I would show you the actual screen for the Cradle cluster. Yeah.
So the Cradle cluster is on the HPC?
Yeah.
So it's a subset of
Yeah,
the
it's a subset of it. It sits on the within HPC.
So by default, if you're a member of the SDLE group, you by default are in the Cradle cluster, or are you by default in the HPC cluster and you have to then migrate to the Cradle cluster?
Really, I don't know exactly how it works, but that's handled by the HPC. So if we give any new username to HPC, they kind of assign it to RxF 131 group, which is SDLE group. And then I think they also give the permissions for this cluster as well. So this is how it works, I think.
So Cradle cluster, everything that you would do in the HPC cluster, correct?
Can you please repeat your question?
So the Cradle cluster is a Hadoop cluster, so it's for distributed computing. It has 180 cores to compute using things like MapReduce or Spark. But that's actually different from how one uses mostly the compute core and GPU cores in HPC, where you basically log into one computer, one core, and run your code, or hash the five core. And the distributed computing is actually architecturally different from high performance.
So can you give me an example of the type of question you would ask to use HPC versus the type of question you would ask for distributed computing?
Yeah, so in HPC, you would run jobs that have a lot of CPU cycles, but they're working on a small amount of data. So if you're going to do some molecular dynamics or some FEA, you can do it on an HPC. It's mostly CPU cycles that are going to be consumed, but it's a small amount of data. The Hadoop cluster for distributed computing is where you want to instead ask a question that's going to be accessing 10 terabytes of data. And the distributed computing will put a whole bunch of CPU cores near the data and process through all of it.
So if you wanted to do something like do image analysis, 10 depending on how many images you had, you would either could do that either in HPC or just
Yeah.
depending on how many you would
Yeah.
have.
And so many times we will store 30 terabytes of data in Hadoop cluster, and if it's going to be running simple Python machine learning, we'll pull the images up in HPC cores, put them on 200 different CPU cores, run 200 parallel single compute jobs, and then write the results back into the distributed.
Yeah, the other way to put that is if you can split your data set very easily, you would prefer Slurm jobs because there are like hundreds of Slurm nodes. But if you are not able to easily split your data set, I think in the end, the size of the data is more than a memory, like more than a compute node, or just like a disk in a one machine, then you would use Spark because you can easily share the same data for different nodes. And this is like really helpful in machine learning applications and if you're using it with Spark. So in that case, Spark would load all of your data in the memory, which is shared across 12 nodes in eCradle system. And then you don't have to load them every time. So this will enhance the machine learning iteration process, especially. Yeah.
As you said about the modules, do we have the permission to install some packages, like if we install some Python packages, do we have the permission or do we need to ask HPC people to install this?
Yeah, so there are two ways. First of all, a simple way, yeah, we can use, if it's installable by pip install, we can do that. Because you're a member of SDLE, so yeah, you can do that. And there should be a specific command to do that we use, like pip install, and then you have to specify the target path where you want to have that. And then at the time of execution, you have to import that path to access that library. But if it needs some external packages, okay, which is not a part of the pip, and then it's not that straightforward. And sometimes we face that issue, and we are still in the process of streamlining it, how to do that, because even I don't know exactly how to create a module. Ideally, will have to create a module, and we will load them, and then we can install using a pip if it's looking for external library. So yeah, maybe in the future we would know how to exactly do that. But in 95% of the cases, you would be able to install the Python packages or R packages, yeah. Okay, so let's move further. Yeah, so unfortunately today, like I have an issue with this, but yeah, you would normally you would get a compute node like really quick instantly. So I would open a new tab for this, and then now I would move to Hadoop cluster. So it's on a different. So the master node for Hadoop cluster is, let me increase the font size. SSH SGLE CDH1. And now I wanted to show the cluster environment. Oh, so since I just used SSH, so I cannot open a graphical interface. So I will have to exit this and again log in by -y option, which will let me use graphical interface. And now I would use Firefox. So this needs a login. So we have our own one for monitoring purpose. So I would just open this one, just to give you an idea how it looks at our interface. So these are the systems that are running on our cluster. The most important of them are HBase, SGFS. Oh, font size. Yeah. So HBase, SGFS. We use Hue to view HBase graphically. Then this Spark cluster. And these are being used at the backend, Yarn and Zookeeper. You will not notice, but they are being used. And sometimes also the others, but not very frequently. So now if these plots, they show the usage of the cluster. So it's all green. That means everything is only being written. Everything is being read from the disk. Sorry, being written on the disk, and nothing is being read from the disk right now. So that's, yeah, so we can monitor these, and these is like 30 minutes interval. If you want to see for a week, you can just click on the tab and then see the pattern for the last 1 week, and so on. Then we have for HBase. So yeah, if all of these are green, everything is like working fine. But if you want to look specifically for any one region, you can go through these plots and then see. But yeah, normally we don't do that. We just look for these. If they're all green, it works fine. And particularly this one, the thrift server, because we intensely use this when we connect Cradle tools with HBase. And then we use Hue. So I personally do not find Hue very useful because it gives us a graphical interface of HBase, which is a like huge database. So it's not useful to like see it on the screen, because you would just find numbers on the screen and you will not be able to figure out. But some people find it useful. So yeah, we have Hue for visual interface. And then Spark for like parallel computing. So this was the graphical interface. Okay. Now let me see, did I get the node? Okay, not yet. Okay, and like one more important point, if you are working on HPC and you have used the resources in your research work, it's recommended to use this acknowledgement to acknowledge HPC, RCCI. And these are some of the resources for HPC help. So you can go to these pages to look for any problems that let's say you want to run some Slum jobs. So Slum jobs is being covered day after tomorrow. If you really want to know how to run those jobs, so please do join us on Thursday at 2:30. So you will find different useful links here. We always refer to these, and then there is something, a new one. So earlier there was a Red Cat for HPC. Now they have recently moved to Rider, maybe a couple of months back. So there are some of the things which are different. For that, we have a different website, but most of them are similar commands. So you will not find much difference here. Still, we have now two different websites, one for HPC and one particularly for Rider. And then this is the email address. If you have any questions or like issues related to your jobs on HPC, they would be helpful. But yeah, it's recommended to have your own task on or your own homework done before contacting them, because it would make the task easier for them. If you're asking some question, explain what you did and exactly what your questions are or question is.
Question over here.
Oh yes.
A little bit ago, you showed the Cloudera manager, and it showed like HBase and everything in good health.
Yeah.
What are some things that might make it have poor or bad health? Give like an example.
Yeah. So there are two important things to look for. One is the memory usage. Whenever we submit data or retrieve data from HBase, we use Thrift Server, and Thrift Server has a limited memory. Okay, even though we have like enlarged it, but still we have a limited memory. So that's the if it's not working, that's the first thing to look for. And very rarely I have seen that disk space gets full, especially when we had an earlier Hadoop cluster, HPC version 1. So, but I haven't seen it lately when we have moved to. So those are the two things I think to look for: the disk space and the memory RAM. Yeah, and so just for a quick. So yeah, you will easily find some. So here we don't have any red markers here. There are a few yellow. That's a warning issue. It's acceptable, but there shouldn't be any red markers. And even if sometimes it's not like visible here, so you have to click on HBase, because most of the time we use that resource and then the Thrift Server. Okay, and if that's the case, then there's a different. So right now we are in SDLE user account, but there's a different account which is the admin account, and then we can restart the process, and then yeah. And if you want to find the reason, look for the logs. So there's a quick link, I think, to look for logs also somewhere. Yeah, so you can look for logs here, like what you did actually and what was the size that you were trying to read or write. Maybe you will figure out. If it's really huge, let's say 100 of GBs, then yeah, you would come to know, okay, because of the memory. Okay. Now I would show you a little bit of Spark. We have like 10 minutes left. Just to introduce what we can do with Spark, like what are the basic commands in Spark. So Spark is a parallel computing framework. If you have a data set and you want to run a query on it, it would do it parallelly for you. But before doing that, you have to set up a Spark, which is already done here, the Cloudera network that I showed. So this shows that a Spark is running here. See this one, it's running. So there are two Spark versions, a Spark and a Spark 2. So we have stopped this one, and this one is running. And it's one of the So it says that it's a large analytic engine for large-scale large-scale data processing. So overall, if you have one machine, so to understand it in a simplest of term, if you have one machine, it has 4 core and let's say 12 or 16 GB of RAM. So it has a limited scope, okay? But if you want to increase these capacity, you would add, instead of buying a supercomputer, you would add new computers and you would add them to the same network, okay? Then you will have to set up a Spark network. There are like certain instructions, you will find it easily. And then once you have the data, once you have the Spark setup, then you can have your data on the same cluster. But it's better to have Hadoop in conjunction with the Spark, because Hadoop is a data storage and it gives you a distributed data storage. So if yeah,
You can't really mark on the whiteboard because people won't see it.
maybe just for one audience, maybe just go through it. So this was your one machine earlier, and then you added other nodes. These are just the computer machines. So not everything has 4 GB, 4, 4, 4. Now overall you got 16. It's not 16, maybe let's say 14 or 13 when you add them. Now, when you have Hadoop here on all of them, so, and this has 128 GB, let's say, disk space. So all of them, so you will have 128 times 4 disk space and 16 GB of memory. So this is how this is the advantage of Spark. Now you can avail a large capacity of disk space and memory RAM.
But I was thinking that this is the purpose of the HPC, right?
Almost similar purpose. In here, it's HPC has a Slum, which is schedule Linux parallel something. So it's for it does the same purpose, and the difference is you have to make the jobs run parallelly on Slum, okay, on HPC. When I say Slum, it's HPC. Like the tool on HPC which makes you run parallel jobs. Okay, but when you talk about Spark, you don't have to take care of running a job parallelly. Okay, when you run a job, it will automatically parallelize for you. You don't have to do that. Yeah, the drawback is with Hadoop here is it has limited nodes compared to the Slum. Slum has like thousands of nodes. Yeah, but it makes easier to implement.
Distributed computing is for working on large data sets. So things that can be 10 or 100 terabytes, petabytes in size. You could ask simple questions and do calculations on 100 terabytes of data at once. You couldn't possibly load 100 terabytes of data onto an HPC computer because it doesn't have enough RAM, right? So it's impossible to do that. And you can HPC job, you can just load small data sets. Like you could, like, people might think of here, like it's a small data set. And we could do something like that. 8 gigabytes of RAM, right? Then you can do that. That's the difference. Distributed computing versus high performance computing. The nice thing that we have here is that we can do both.
So we have like few minutes. I would quickly show what we do on Spark or what we can do on Spark. So right now I'm showing you just a file that is there on a Hadoop system. And this is the command to list. I've kept it in a temp directory. Time. Oh. Yeah, so here we have 2 sample files. If you want to see. Yeah. So what I did, I came to Cradle cluster, which is Hadoop cluster. Then I listed the files that are there. This is the command SDFS. So whatever command you want to run, SDFS, DFS is kind of the prefix to that. And it's kind of, most of the time, it's similar to the Linux command. So here we did ls to list. And then we would do .json is kind of the standard file for PySpark. And to view this, we would use cat. So there are 3 rows in the JSON file, just to show you. Michael, Andy, Justin are the names, and the ages are 29, 20, 30, and 19. Okay. So this is the Spark. There are some warnings which shouldn't be there, but okay, for time being, we can just see the work. So these are the ways to read. So if you want to read the data, these are the commands this file will be there in the repo, so you don't have to worry about this. And now you want to see what did we read in. So df.show would kind of show you what was there. It's more of similar to dplyr package in R if anybody has used it. And then the schema is kind of, okay, so we have two columns now, age and name. So this is very easy. Once we have the data frame here, it's relatively easier to work in PySpark. And let's say now I just want to select the name, which is again very similar to either SQL or either dplyr. So see, we can just pick name. If we want to apply some query, we can do that. Let's say I want only those who are more than the age 21. Then I can do this. So Michael and Andy. So these are some of the commands. And similarly, I have the other for if you want to use text file or CSV file, you can use these. And if you are familiar with dplyr package in R or SQL, you can easily use PySpark for your analytics purpose. I would save this file and see the similar command is group by. You can use group by. So all of them are just one. So in Spark, there are two kinds of commands. One is a lazy command and one is the action command. So like show is an action command, but this was a lazy command. So if you run this, nothing would happen. It just saves for if there is some action command, then only this command will be executed, like show or collect or any other calculation, any other projection that you want to do on the screen or something like that. If you would do something like this and then assign it to some other variable var1, yeah. So yeah, now this is again a lazy command because we are not doing anything here. But when we would show it, then it would be an action command, and that's where the actual processing is done. So this was kind of introduction to our HPC and the Cradle infrastructure and some of the tools that we use. Any questions? You can get back to me at the email address that I showed earlier, or yeah, that's the best way to access. Okay. So thank you, everyone.